So I'm Sherry Wei. I'm the founder and CTO of Aviatrix. And in this section, we're going to talk about software-defined routing, cloud routing. So what do we mean? So we think the networking landscape is changing. Traditionally, networking is about, we think data center networking is west, south, north, and also about branch to the data center, about user to the data center, right? What we've seen in the last couple of years, a lot more and more traffic are towards the cloud, and cloud deployment gets bigger, a lot of the challenges and also opportunities are about how do you connect your data center, how do you connect your customers, your partners, and your branches to the cloud, how do you connect your people, and also in the cloud, how do you control egress traffic to the apps where they need to visit different sites and even do different API calls, and how do you go to different clouds. So the shift of the focus are more and more towards the cloud networking, and obviously, we talked about the uniqueness and therefore the challenges.
What do the delegates think of a more cloud-focused view of networking? Is that going to happen? Is that happening already?
Well, it's inevitable. I mean, it's going to happen. My company it doesn't lag behind, but it's never on the front edge, right? Kind of in the middle with change and progress, and we're deep into putting fabrics in instead of putting networks in, right? And it's may not be public cloud, but it's just abstracting network is what has come and what will continue to come.
So we'll share with you today about the public cloud space and the challenges, and along with our customers' journey and how we solve those problems. That's our focus. So then let's double click and see. In that public cloud domain, that space, we said that there is virtualized router, right? Any hardware vendors you can virtualize and you play in the cloud. When you put it in the cloud, my first analogy is kind of like you put the router, you virtualize, you deploy as an instance. It's kind of a router without cables. Until you put the cables in, you can configure all you want, but it won't move any traffic, it won't move any packets, right? Because they're virtualized, they're an island of their own. You turn them on, you configure all of it until you hook the cable, meaning you program the infrastructure to point the routes to them. No packets will be forwarded to them. So that's virtualized router. That's one attribute of it. We'll talk more about it.
Has anyone experienced using a Cisco CSR, for example?
Yeah.
And would that analogy work for you in terms of hooking it up? Okay, I see heads nodding.
Yeah. And then in the cloud provider themselves, they all provide compute storage and they also provide networking, right? But our view is that their networking is kind of like a pipe, like primitives. I can set up the VPC, I can do some peering, but you still need services and policies on that. And you build in on top of that, there are many areas that services can be provided, and they also always have limitations in terms of routing table entries, in terms of security group entries, in terms of how many IPsec tunnels you can hook up out of VGW. The scale size also has limitations. So what does that mean to do a software-defined cloud routers? That's what we do. We build from ground up for that. So what does that mean? First is deep integration with public cloud providers, native services. That's kind of like saying that once you boot up that router, you set it up, the cables are already wired in. The cables are set up by the Aviatrix, by the product itself. You do not need external the softwares or scripts to hook it up. And there's more to it. I'll get down to in the later parts of it. Another part is centralized control and management. That is very important in the public cloud space because earlier we mentioned about the scale of VPCs, right? To manage one data center is one thing, to manage hundreds of them, hundreds of VPCs, and to connect them to on-prem, to connect them to each other, to connect them to different cloud, and that itself is a challenge. Without a centralized controller, it is SSH logging to each one of them configured, that is become unmanageable. It's hundredfold of difficult. I wanted to see if that makes sense to you guys.
Yeah.
It's a different scale of problems altogether. The third one is use case driven network services. You know, you think about the traditional routers, it provides nuts and bolts, COIs. And you have to learn and figure out how do I put the nuts and bolts together to make it into a deployable use case, right? Now, that makes things very complex, and you need to learn all the detail. In the cloud, we are much more use case driven. We're going to talk about use case later. That provides a level of abstraction so that the user just need to know, I need to do this use case, and I do it a few buttons or a few APIs, that use case will happen. So that lowers the bar, enable more people, your operations people. Maybe you are the architect, you can architect this, but you probably cannot hand off to another guy if it requires nth level of degree of understanding of each nuts and bolts. Right? There is another advantage of use case driven, that is, it enforces a discipline of design patterns. Because it has been extracted, now in the cloud we talk a lot about design patterns. There's this design pattern for this use case, so that then it becomes more cleaner design, scalable design once you have a repeatable patterns and you keep going. Instead of ad hocly thinking about, I need to hook up this, I need to hook up that, I need to connect this. If you look at the cloud networking, people talk about patterns are much, much more about, and that's because there's a use case to it. Make sense? Okay. The fourth one is performance, and this is a very critical to if we're all coming from data center networking, right? In the data center, if you don't have wire speed, you can just shut up. Nobody's going to deploy most of the time. So in the cloud, when it is software, it's all instance-based. And if you cannot really provide wire speed, you don't have that performance, then it's very difficult to run a production mission-critical network at scale. Right? And currently, the industry benchmark for IPsec is below 2 gigabit per second, and that is the cloud provider themselves and the vendors. It's all capped like that, and that will become the bottleneck, and that will make people make a lot of compromised decisions in order to be able to run at wire speed. For example, they probably will say, I will not encrypt, I will not do security process, I'm afraid of this, afraid of that. So that's another key point. The last one is building security policy and encryption. We believe that encryption and policies are the new baselines for the cloud network, public networking. Data needs to be encrypted. The cloud providers already do data encryption at rest, but data in transit should be encrypted. That is not just compliance, but also risk management and the good security posture. So those are the 5 key, we feel, that differentiation for a software-defined cloud networking.
I'd like to just add, so for the folks that did use a virtualized cloud router before, does this feel like, in terms of a software-defined cloud router, a good list of 5 things that we think is an important designation for software-defined cloud routers? Love to hear your thoughts.
Number 4 is a little bit vague on the performance side. Performance beyond 2 gigs. So you're just trying to make sure that each instance can do at least 2 gigs? On
an encrypted basis.
More than that. We want to talk about wire speed.
Okay.
Yeah. We do not want a performance to be a problem of deploy. Does that make sense?
Because the data center side has much, much higher performance, and you can get a direct connect at 10 gig. However, in the cloud, if you want to encrypt, it's not going to be anything close to that, right? And we think that the software-defined cloud routers need to take it to another level of higher performance because you'll need that as more and more traffic happens in the cloud.
Yeah. The industry needs to move forward in that front, basically. Does that make sense?
Any other comments?
I
You've
think
used the
big
virtualized
thing-
routers before.
Yeah, I was talking about around number 3, we were talking about use case driven networking and having a pattern already set up and defined. So I think you always talk about with networking, give kind of the least amount of access that you have to. And if you've got the pattern already set up for whatever application we're talking about, now you bring on another account in AWS and they need the same thing. Well, if you already have the pattern built, you've fully gone through it, made sure all the details were there, every bit of access is defined already. I mean, yeah, it does absolutely make it quicker if you're spinning up another VPC.
Yep.
So doing that traditionally, I mean, there's definitely a process to doing that, but I think the point of maybe you can hand that off to somebody who doesn't know the more advanced side,
Yep.
and they could quickly, add another VPC, another,
Exactly.
application or something. I think that's definitely some value there.
And so we think being prescriptive is going to help, and there's something called landing zones that AWS promotes, and we're one of the only networking partner for that at their launch, and so that's in the future coming, and we're pretty excited about that.
Actually, we had 7, and to fit it into space, we put it 5. There is another one like network as code, so it needs to be API driven. Terraform, we have a Terraform provider, so you can run Terraform, you can run Python SDK, you can run API, but that is a taken. So this is more like functional level, performance level.
A show of hands, do you run Terraform in your organization or have those automation techniques here? Not yet?
Not Terraform. Yeah.
Okay, great. Okay,
Okay.
go ahead and.
So here's a high-level definition of our product. We have a controller, provides single pane of glass, and it does it's multi-accounts and multi-cloud, and it allows a browser-based access. It also allows the API. It also allows Terraform to drive to the controller. And from the controller, you launch the gateways, and the gateways can be in the cloud, can be on-prem, and then from the controller, you also build connectivities. This I'm just going to click through because there are patterns for how the connectivity should look like. But for now, let's just say it builds connectivities, does the HA, does the keep alive, does the switchover. It's the brain of your network. And the gateways are the worker bees, the guys who move packets and the guys who does encryption, decryption, and does policies. But the brains are in the controller in terms of how it's going to do. So in the get-go, there is a controller there.
And this system is, I'd like just to add, it's a gateway, lightweight gateway per VPC, so it's agentless. And other companies their technology is agent-based, so every instance needs to have an agent. We do it in a gateway-based way.
Yeah.
What do you think about that?
Yeah, I think as far as deployment, that certainly simplifies deployment, and getting permission, getting someone to say, yes, we can install these agents can often be an issue. So the agentless model, I think, is great. The controller, that exists in the public cloud?
AWS, Azure, or Google.
Yep.
Okay.
Yeah, and one of the things, it's our philosophy, is that you cannot ignore what public cloud providers provide. You cannot ignore their infrastructure. You cannot build a pure overlay and route all over yourself, right? So our thing is within VPC, EC2, talk to EC2, they use their underlying infrastructure. Whenever we can, we write on AWS backbone, we write on Azure backbone. We provide service on top of that. You cannot ignore, because there are lots of security groups and the underlying connectivity is built in, and you should leverage that and build service on top of that. So that's why we do not. Yeah.
And just adding that as a reminder that the controller is it's a software-defined controller. It automatically discovers the public cloud VPCs and the network layer.
Right,
So
because-
that is why
right.
it's not just a virtualized router.
Yeah, one of the things the controller does is because it manages your AWS account, so the IAM roles, the credentials, your public cloud credentials are put on the controller, so the controller can launch using the public cloud provider's API, launch these gateways on your behalf, basically. So that's why it's all completely automated. The controller has all the visibilities of the, by the way, okay.
So can you elaborate on that, excuse me, just a little bit more? My experience with public cloud networking is just building IPsec VPNs between my on-prem firewall and the public cloud. So when you say you can't ignore what they're doing for networking in the public cloud and just, route over it and peer, why can't I just spin up a CSR and tunnel everything to that device and ignore what they're doing?
Yes, so in a way, we are also that virtual appliance, the instance, and can connect it to on-prem. What I meant is there are solutions out there where they would install agents into every EC2. So when EC2 needs to talk to another EC2, we'll go through this gateway and then connect. So what we're providing, the same as what you're thinking about the CSR, is the gateway is the boundary of the VPC connectivity. Right, so the way think VPC EC2 to EC2 connectivity is using AWS underlying infrastructure. In fact, unless you install agent, you can't even route that traffic. The traffic will not even come to you. The routing is within the VPC. The packets won't even come to you unless you put an agent in there. But that is what people wanted. They want to leverage the native connectivity.
And to answer your question, maybe at a small scale you could do that. However, if you're talking about a larger scale of VPCs, then our controller is an orchestrator too. So it orchestrates all of that. Okay.
You had mentioned AWS, GCP, and Azure. Any support or planned support for OpenStack, either hosted with various OpenStack providers or even on-prem? The reason I ask is because there are certain regulatory restrictions in European countries especially keep them to companies like Deutsche Telekom running OpenStack as opposed to going to other providers.
Right. So the virtual appliance, this thing can sit in. It's a OVF. So it can sit on. It can sit on. It sits on EXSI, can sit on VHD, which is Azure, can sit on the third one, just skip my mind, KVM, right? But what this special thing the controller does is it runs APIs, in infrastructure APIs, for example, AWS APIs to program routing tables, to program route entries, right? But we don't have that for OpenStack, and we do not support that. Yeah.
Any planned support for that?
We'll have to see if there's a big customer, if there's a real momentum, we will consider maybe we can talk offline if you really feel that there is a big market for that. Okay, so that's kind of on the high level what our product does. In terms, and we also, we are a big believer of best of breed. So whenever it's possible, even from the controller, you can do AWS native peering so that you can have single pane of glass for your network connectivity requirements and security requirements.